Okay, lesson 11.2, solving linear systems by substitution. So just like in the previous lesson, we're learning to solve a linear system. So our special cases still can apply here, where we can have no solution, which happens when the lines are parallel, and infinitely many solutions, which happens when we get the same exact line. So it's going to look different by this method. So it's still doing the same thing, again, just in a different way. So how does substitution work? Well, you can go through this example. Looking at substitution method, right here they give you steps to do, to go through, which is not bad to look at, and the full example. I'm going to go straight to the your turn problem and do this one. So when you're doing substitution, what you're really doing is you're trying to get one of the variables isolated. Always look for one that has a coefficient of 1. In this case, the y has a coefficient of 1. So I'm going to take this equation, and I'm going to get the y by itself. So I subtract by 3x. Looking for a coefficient of 1 allows you to avoid fractions. So you get negative 3x plus 14. And again, sometimes you're just going to have fractions, but in this case we don't. So what we want to do is we want to take this expression, we want to plug it in for y in the second equation. So now this equation becomes 2x minus 6 times, no longer y, but the expression we just solved for, negative 3x plus 14 equals negative 24. Now what this does, now creates an equation where the only variable we have is x. So now we're just solving an equation. So I have 2x, distribute your negative, pay attention to signs, negative times negative is a positive 18x, negative times positive is a negative 84 equals negative 24. Combine your like terms, 20x minus 84 equals negative 24. Oops. Add 84 to both sides. So when I do that, I get 20x equals 60. Divide both sides by 20. And now we get x is 3. Well, again, this is a system, so they should intersect at a point. Well, that's only the x value, so how do I get y? All I have to do now is take this and plug it in for x into this expression that I solved. So I'm kind of running out of space here, but I'm going to try to squeeze it in. So right over here I have y equals negative 3 times x is 3 now plus 14. So negative 3 times 3 is negative 9. So I have y is negative 9 plus 14. If I add that, then I get y is 5. So then I know they intersect at the point 3, 5. And again, a good idea would be to substitute it back into each equation, make sure it works. So if I come back here, 3 times 3 is 9, 9 plus 5 is 14. 2 times 3 is 6, 6 times 5 is 30, so 6 minus 30 is negative 24. So that works. So this is how substitution works for solving a system of linears. So again, one of the things you can do is always go back and look at it graphically to make sure it matches. Now, in this case, we're going to be practicing substitution because you need to know all the methods to use. However, if we're doing these, you always want to make sure that you find a method that works for you and then do that. So what I would like for you to do is work with me here on number 7, and I'm going to give you a chance to try number 8 because our special occasions still occur. So what does that look like? So in this case, again, look for a coefficient of 1. The x has a coefficient of 1 right here. So I'm going to solve that equation to get x by itself. So it's not always getting y by itself, it's whatever variable has a coefficient of 1 if possible. I'm going to take this and plug it in for x in that equation up here. So I now have -2 times 7y plus 14 plus 14y equals -28. Do your distributive property. -14y minus 28 plus 14y equals -28. So what happens to these? They're opposite, so they go away. So I'm left with -28 equal to -28. Well, when does that occur? Well, that always occurs. This is a true statement. So we're going to learn something now in math. Anytime you get a true statement in math, that means the answer is always true. In this case, that means this would be infinitely many solutions. Now, how does that occur? That occurs because basically these two equations are the same exact equation. If you got them both in slope-intercept form, they would work out to be the same exact equation. So they're graphed right on top of each other. So what I would like for you to do is to try number 8 here on your own. I'll give you a minute to do that. You can pause the video and then go back and check. Okay, so what I've done is I've gone ahead. Again, this had a coefficient of 1, so I got y by itself, took that expression, plugged it into the other equation for y, distributed a -2, pay attention to your signs. My like terms here cancel, so I'm left with -24 equal to 18. That is a false statement. That is never true. So what does that mean? That means graphically these two lines are parallel. So if you got both of these in slope-intercept form, they're going to have the same slope but different y-intercepts. That means they never cross, which means there is no solution. So if you're solving by substitution, the two special cases are if you get a true statement, it's infinitely many. If you get a false statement, it is no solution. So it continues on with this by doing a word problem and implementing it. So what I'm going to do is I'm going to go straight to the your turn. We're going to look at it, and then I'm going to give you the assignment. So right here it says a boat travels at a rate of 18 kilometers per hour from its port. It gives you the second one. It goes through everything, and then all of a sudden it gives you both equations. Well, this one's pretty easy to solve because they are already solved in terms of being written out as the equation. So all I'm going to do is I'm going to take this 22D and plug it in for that D, 22T, sorry, equals 18T plus 34. So now I just get T's by themselves. So I subtract 18T. So that gives me 4T equals 34. I divide by 4. And then if I do that, that's going to give me 8.5. Now, what does 8.5 represent? That is my T or my time, 8.5 hours. Okay, so it says, how many hours will it take for the second boat to catch up to the first one? And there we go, 8.5 hours. How far will the boats be from their port? Well, now I need to plug it back in to get their distance. Which one do I plug it back into? It doesn't matter because you're saying it's where they're equal. So in this case, I'm going to plug it into the second one. D equals 22 times 8.5. So if you multiply that out, you should get D equals 187. Go back to look at your units. They were kilometers. So you can say 187 kilometers. So for this, you are doing page number 497, and you are going to be doing numbers 1 through 19 odd.